Hi everyone, thanks for tuning me. Thanks for tuning me. Thanks for tuning in. What's the problem? Okay, what do we got? We got a right circular cylinder, and what we got to do is try to find the dimensions of it, okay? So here's the problem. We know that the radius and the height are going to differ by 2 meters. And it says that the height is going to be greater. And it tells us the volume. So basically, how do we find the radius? How do we find the height? So just take it piece by piece, all right? So first, just label the important parts. That's the radius, and this is going to be the height. So just start with R and H. Then it says the radius and the height are going to differ by 2 meters. Okay, do we know which one, though, is greater? Well, yes. It says the height is greater. So what that must mean is that if you know the radius, then the height must be 2 more than, or 2 meters more than the radius. Right? So if you know the radius, then the height is just simply going to be 2 meters more than the radius, because the height is greater and they differ by 2. And then it tells us the volume. So I'm thinking to myself, how is the volume related to all this mumbo jumbo? Well, the volume is going to be equal to pi r squared h. For a right circular cylinder, what happened to the h? It looks like an L. There you go. So the volume, they told us, is going to be 28.125 pi, and that's going to be equal to pi times the radius squared, which you just called r, times the height, which you said is r plus 2. So the pi's just go bye-bye. So what you're left with, I'm just simplifying it now, is 28.125 is going to be equal to r squared times then r plus 2. Now, if you don't have the calculator to solve this, it becomes really, challenging, and it's actually it's a long process. All right, there's several ways you can do it. One of the ways could be to use the rational zero theorem, in which case, if you're not sure how to apply that, just take a look, just Google Glaser Tutoring and just type in rational zero theorem, and a whole bunch of videos will come up. I'll walk you through how to do it. All right, and you can apply it for this. But in this particular case, what I'm going to do is, and in order to use the rational zero theorem, you want to have this set equal to 0. All right, so I'm going to do that anyway, regardless. So let's just set this equal to 0. So you're going to subtract the 28.125 from both sides. So you're going to get 0 is going to be equal to r squared times r plus 2 minus then 28.125. All right, and then from here, what you'd have to do is you want to distribute this so you get it in terms of, ar cubed, plus then whatever b r squared, whatever it winds up working out to be. And then you can kind of use the rational zero theorem on that. But for this problem, what I'm going to do after I get to this point is I'm going to take this value now, after it's set equal to 0. I'm going to take this equation, not value, but, well, it is a value if I know the value of r. I'm going to take this basically and just plug it in for the y equals. Okay, so you're going to do, instead of r, we're going to use x. So x squared, open parentheses, x plus 2, close the parentheses, minus 28.125, and hit enter. I meant to hit graph, sorry. Hit graph. Now, so anytime you set an equation equal to 0 here, the value of x, where the function crosses that x-axis, is then a solution. In other words, we can almost see that this is roughly about 2.5, right? But how do we know if it's 2.5? Well, what you can do is you can go to second trace, meaning you're bringing up the calc function, scroll down to 0, and this helps us calculate that 0 value, okay? You got to move the cursor to the left bound of the point. So if you know this is 2.5, just make sure that this number is less than 2.5. So somewhere around there is good. You don't got to be you don't have to get too crazy about this. Just go to the right someplace that's good, and then guess where it is. You don't have to be even that close. That's close enough. Watch. Boom. Calculated it for you. All right. So this is the x value, and remember that's the same thing as the r in this problem. So if you were to plug in 2.5 for r, guess what? This whole side would become 0. And that's the benefit of setting any equation equal to 0. All right, is that if you can then find the intercept, the x-intercept, that is a solution. So in other words, the radius, what we just found, is that the radius is going to be equal to 2.5. And if the radius is equal to 2.5, and you know that the height here was 2 meters more, then the height should be 4.5 meters. And let's just see if this works out nicely. So remember, the volume is going to be equal to pi r squared times the height. So the volume is equal to pi times the radius squared, which is 2.5, square it, times in the height of 4.5. And what does this work out to be? Well, you can use your calculator, right? Just do, you don't have to plug in the pi because it's in terms of pi. Just do 2.5 squared times 4.5. And there it is, 28.125, right? So 28.125, since I didn't factor in the pi, it's in terms of pi, and that's exactly what the volume should be. So we know we're right. That's all there is to it, ladies and gentlemen. So thank you so very much for tuning in. If this helped you out at all, if you don't mind giving us a like, subscribe, maybe even, sharing our channel with your friends or whatever, or even your classmates. And you know what? If you share our channel, your classmates may become your friends. All right. Nothing is the same as giving the gift of learning. I don't. That was just absolutely terrible. I'm not really sure. Just trying to think of things on the spot. Trying to be spontaneous. Spontaneity. For some reason, when I think of spontaneity, I just think of Gibbs free energy and all that stuff. When you learn enough science and you do it frequently enough, all these common terms just take on different meanings. Anyway, hope you're doing well. Do you mind if I have a conversation with you right now? Because I've been talking to the computer a lot, and I'm going a little cuckoo, So I'm just going to, how you doing? Hope your semester's going well. Or your year, right, depending upon if you're in college or high school. And, just keep working. That's really the most important thing I can say at this moment. Just keep practicing. Don't give up. Never give up. Never settle. Actually, college, I took a psychology class. It was like intro to psych. And the teacher said, one of the best pieces of advice I've ever taken from my entire college career was all he would say is, never settle. That's it. He's like, if you leave this place with one thing, just never settle. And I didn't really think anything of it at the time, but he was totally right. Never settle. If you feel like you're settling, move on, move upwards. Okay, never settle. All right, always strive for better. All right, and then when you find the thing you're meant to be with or do, whatever that is, you're not settling anymore, even if you're staying stagnant. You've achieved what you wanted to achieve. All right, but keep striving. Never settle. Thanks for tuning in.